Alright, good morning. This is our second lesson. It is Tuesday, March 17th. This is for Trig-Precalc. This is a lesson on 3.2. I watched the video for my first trig lesson. I say the phrase a lot. I'm going to try to cut that back. I also received a question from one of you about what it means not to have a solution, so I'd like to start off with that. And actually, before I do that, I would like to let you know that I hope I'm thinking of you guys. I hope everyone's doing okay out there, and thoughts are with you guys. And I'd actually miss teaching the class, which I can't wait for things to go back to normal. Anyways, you'll notice there's a little slight different change from the last time, yesterday, the first time I presented. I'm actually now at my house. They don't want teachers coming on campus, so the school's closed to even us. I hung up this whiteboard last night, knowing how important it is that you guys get homework. So since I'm filming at my house, you're going to hear some dogs barking, cars going by, me getting distracted by people parking out in front of my house, wondering who they are. Anyways, Let's go ahead and get started. So I would first like to answer that one question I was asked yesterday. That was, I didn't quite understand what it means no solution. So let me write something like this, and hopefully I can articulate to the point where it makes sense to you. If I was in fact to tell you log base 2 of -8. Now remember, we want to know what exponent this needs to turn into that number. And if we call it x, we would get, we wrote it as an exponential, it would be 2 to the x power equals to -8. Now, it is a fact that 2 to the third power is 2 times 2 times 2, which is 4, which is 8. I cannot multiply this number to itself and get a negative number. The answer is going to have to be positive. So when we have this situation where you solve it and you're checking it and you were left with something that looks like this is not possible. And again, it's not possible because I can't put an exponent there so that when I multiply this number to itself 3 times, a positive times a positive times a positive, I won't get a negative. The result has to be a positive. So I hope that helps clarify some things as to why there's not solutions. Today's lesson is really simple, really short. I'm going to say again. The lesson, it's about 2 specific logarithms. And so let's just add this to our cheat sheet. And to be honest, we're not doing anything new today. Okay. I said it again. Let's see here. Let's add something to our cheat sheet. Base 10 logs. Okay. So, if I was to say log base 10, I don't know, of A, that's the same thing as saying just log of A. So if there's no base number here, it's implied that there's a 10. That's one of the new things. The second specific base that I want to talk about is a number that was actually created. And it's actually a pretty interesting number in the fact that it comes from an exponential equation. Euler discovered it. Euler, really important guy, mathematician. But anyways, if you take the following idea, 1 plus 1 over n, and you raise it to the nth power, and you keep making n larger and larger and larger. So you're adding a fraction to 1, and then you're raising it to a very large power. As the power gets to be larger, the value of the fraction gets to be smaller. So you're actually adding a very small number to the number 1 as this gets to be very large. And so since this number gets to be smaller, it actually, you're adding it just, since you're adding something very small to 1, you're not going to get a very large growth. You're actually going to be limited as to how large this gets. So this fraction that's adding to 1 gets closer to 1. It gets really, really close to 1. However, if you were actually to calculate this out, you would, put any value, large values, 100, 200, 1,000, 5,000, a million. The larger the values that you put in, you're going to get this number. And what's going to happen is it's going to change. And I only memorize it to 2 decimal places. It's like pi. I don't know. It's 3.14. This is 2.71. We call this number E. So whenever you see an E, I'm telling you that it's this number. So let's add this to our cheat sheet as well. We're going to say that the value of E, and we're going to call it 2.71. Again, we don't ever really need anything beyond that. And when this is my base number, if I was to have log base E of A, what I'm going to actually do is I'm going to write this in a completely different way, and I'm going to say ln of A. But when I say ln of A, ln is what we call the natural log. So ln is what we call the natural log. So here I'd say log base E of A, but the correct way would be to say the natural log of A. Or ln of A. But it's most commonly called natural log of A. So again, just know that if you see natural log of A, it's actually this. And if you see log of A, it's actually log base 10 of A. So that's one of the things I wanted to talk about. So what I did was I just made a worksheet that has problems only using log base 10 and log base E. And that's all we're doing today. It's, I think, 12 problems. So you're rewriting them as exponentials, you're rewriting them in logarithmic form, and then you're solving equations like we did yesterday. So that's going to be our lesson for the day. I hope everyone is still doing all right, and thoughts are with you guys. I will post the next lesson tomorrow, and have a good rest of the day.